Hello, this is Radhes from the Programming Club of IIT Madras, and today I'll be giving out the solutions and hints for Codeforces round 876, problems A, B, and C. So yeah, let's start with the problem A. So this is the first problem, the good array. I hope you all reread this problem. So the main point is that in an array from A1 to AN of length n, it should satisfy both these conditions. So at least ceiling of I by k of the first I elements should be 1, and at least ceiling of I by k of the last I elements of the array should be 1. Now, now they asked us how many ones should be there, like how many minimum number of ones should be there. So let's see. Let's take an example and see how it works out. Let's look at 9 and 3, where 9 is the length of the array and k is equal to 3. Okay, so these are the 9 places. Now, this is I is equal to 1, I is equal to 2, I is equal to 3. Now, before I is equal to 1, there has to be at minimum one number of ones. Before I is equal to 2, there should be minimum one number of ones, because ceiling of 2 by 3 is 1. And before I is equal to 3 also, there should be one number of ones. So let's write 1 over here. Now similarly, from here to here, from my index 4 to 6, there should be at least two number of ones before each of those indices. Now, it would be best to keep the 1 over here. Similarly, we have the same thing for these three. Let's keep the 1 over here. Now, are we done? We are not done, because we have the second condition. Now, we have to see from the right side. If we see from the right side, we must put at least 1 here. But after that, for every single element, the condition is satisfied. So we require 4 ones. Now, you may say, uh, why must this be the case? Well, it's a bit intuitive. Let's check it out for another case. Let's check it out for 5 and 2. So let's put one here, and let's put one here, and another one goes here. So here the condition is satisfied immediately, and there is no need for extra. So 3 ones are required. Now see that there are 8 total elements here, and there are 4 total elements here. So in the first 8 elements there are at least 3 ones, and in the first 4 elements there are at least 2 ones in the second case. So observe that the positions of the ones are at uh, index 1 here, and then index k plus 1, and then index 2k plus 1. So we can say that in the first n minus 1 elements there are ceiling n minus 1 by k ones, and there is also one more one at the end, so plus 1. This is the answer to the problem, and I hope that there should be no problem in coding this. Now that we have finished problem A, we'll move on to problem B. The code for problem A was pretty simple. We just have to apply ceiling. Okay, so for problem B, I will tell you the main points now. There are n lamps. Each lamp has a parameter AI and BI. A lamp can be turned on, can be off or broken. Initially all lamps are off, and in an operation we can select one lamp that is off and turn it on. You cannot turn on broken lamps, and you will receive BI points for turning the lamp on. Note that if a lamp is broken after it was turned on, it is no longer considered as turned on. After each operation, all the lamps which had AI less than X, where X represents number of turned on lamps, they will all break. Okay, basically they're asking us if you can perform any number of operations, what is the maximum number of points we can get? Let us look at some examples to gain some insight. So, this is the first example. Intuitively, we will first turn on this because it has largest BI. That is the first operation. If we turn that on, what happens? After that, all of the lamps with AI equal to 1 break. And then we will turn on this, and then this lamp also breaks, and then there are no lamps left. Points that we got 15. Next example. Intuitively, let us start from smaller AIs, because if we turn, let us start from smaller AIs. Okay, turn on this, all is fine right now, no lamp is broken. Let us now turn on this one. Now two lamps are on, so this breaks. Note that no lamp with larger AI can break before smaller AI lamps break. Now let us turn on this, and now let us turn on this. Now all lamps of AI equal to 3 break. The total number of points that we get is 14. For the next example, we turn on this, it breaks, and then we turn on this, nothing's, and then let us turn on this because it's the largest BI for AI equal to 3, and then both this breaks. As you can clearly see, what is happening is that before any lamp of AI equal to 3 breaks, all smaller lamps are broken. So then we can do these two, and then these break. So basically, we will be able to take AI lamps, we will be able to take AI lamps which have AI as the parameter. So basically, we can take any 3 lamps of parameter AI equal to 3, any 2 lamps of parameter AI equal to 2. And if there are less than 2 lamps of AI equal to 2, we can only take that many which are there. So that is the logic, and let us look at the code which I wrote for this. This was my code. This is the main code. Uh, so what basically I did was I associated each element with the AI and the BI using pair of array of pairs basically. So I took the input, and then what I did was I sorted this array. So what is happening when I sort this array? Uh, All the elements are first sorted based on AI, and then the secondary sorting is done based on BI, because the pair is take because in the pair the first integer is AI, second integer is BI. So I want to take uh, the elements which have the most BI in each of the AIs. What I mean to say is I wanted to take for AI equal to 3, here I took this 4 one and this one and this one. I am taking the largest BIs basically. So what I'll have to do is I'll move from the back of the array, and I will take at max I will be able to take AI number of elements for each parameter which has AI. And if there are less elements than the value of that AI, I will only take the number which are there. So applying that approach, uh, we will get I wrote this code and it works. Yes. So yes, hope you understood the intuition behind this, and we'll move on to problem C now. Now let us move on to the C question. So in a C question, there is a sequence of ones and zeros of length n, and also there is another sequence B which is initially empty. So we will perform some operations on the sequence B. We have to convert this sequence B to the sequence that is given by doing this operation. Now this operation is given as we choose a position uh, right after BI, and we insert 0 over there, and then we invert all of the numbers before uh, the portion where we inserted 0, and by invert I mean 0 becomes 1 and 1 becomes 0. Hope you understood uh, the main points in this problem. Please go through it once by yourself if you have not understood my explanation. So let us think how to approach this. Also, if it's not possible to convert, then we have to say no. If it's possible, we have to say yes, and we have to output the positions where we inserted 0. So intuitively, the last element of AI of A array A must be 0, because just think, if the last element was 1, then uh, how would we make the sequence be such that last element to be 1? We can't, because we can only insert zeros, and elements before 0 are inverted. This means that uh, the last element must be 0. It cannot be 1, because we only insert zeros, and to get a 1, the only way is to invert a 0, and only elements before the inserting 1 in only elements before the position where we insert the 0 will be inverted, which means that the last element must be 0. I won't be giving rigorous proof, but the answer will be yes for all cases where the last element is 0, and will be no where the last element is 1. Let us think of an operation sequence. Uh, so we can write an algorithm for each sequence which ends with 0. So observe that there is we can do the inverse operation also on A. What is the inverse operation? What I mean by inverse operation is we will remove 0 here and then we will invert this. Is there a sequence of inversions such that we can convert this array to an empty array? Is it there or is it not there? Observe that if in the ending there are only ones, it means that we cannot perform any more operations. Now I will tell you a sequence of operations. Uh, I will tell you an algorithm which is very intuitive, which we can use. Hmm. So let us take the first example, 11000. So 11000. If we remove this 0, we will get the sequence 0 0 0 0. Then we can just keep on removing the first 0 4 times. And yeah, and now we are done. We have an empty sequence. Observe that what we are doing is we are removing all the zeros in the starting of the sequence recursively, and then we are removing the first 0 after continuous sequence of ones, such that we invert these both ones to 0, and then we keep on removing the zeros at the starting. This is very intuitive. So these are the inverse operations. All we have to do is reverse the indices where we removed the 0 and then write it as the answer to convert an empty set B to array A. Now, how did I code this? My code might be a bit confusing, but let me just explain what I did in a very general fashion. I first created an array uh, which will store the indices where we move 0. This is just an hash define which takes an array of n elements. Now, I just said if the last element is 0, then then print yes. If it is no, then print no, and then come out of the function. Now this is just some stuff that I'm using to solve the problem. Basically, what I did is, let's take an example, 0 1 0 1 0 1. Whenever I am removing the 0 at the start, the indice which we're removing will be itself just 1. So if I remove this, I am removing a 0 at indice 1. Now what I'm doing, I am moving forward in the array until I find 0. I found it here. This is at indice 1. So I will add that uh, into my index array. I will remove this and then it will be converted to, this is inverted. Now what I'll do, I'll remove this because there's 0 at the starting. Now there is no 0 at the starting. At the starting there is 1. So I will go to this first 0 after the series of ones. Move this will convert to 0 1 and remove this. As you can see, here it is not possible because last is 1. If there was some 0 here, simply I would remove this now. This would convert to 0 and then we'll remove this. And that is in essence what I'm doing. Let me just writing 0 1 1 1 Let me write like this so you can see. So remove this 0, and then we have 1 1 1 0. Now find the first 0 after the series of ones, which is this. Remove it, convert all these ones become 0, and now we can just remove this first, remove this first, remove this. So what are the sequence of indices which we got? It is 1 comma, this indice is 4, and then comma 1 comma 1 comma 1. This is a sequence of indices in reverse order. So we just print 1 comma 1 comma 1 comma 4 comma 1. That is what my code is basically doing. Okay, so that is the editorial for this contest, problems ABC. I could not solve D and E in this. uh, so hope you enjoyed this tutorial, and if you have any doubts, please comment in the comment box and like and subscribe our channel. Hope you keep doing problems on Codeforces and having fun. So yeah, thank you.